Okay, so previously you guys already know about stack application infix to postgre, and you guys have also done that in your exam also. So no issues there. Then okay. Now next one is our queue operation. Okay. So how a queue operation works, and queue operation you already know that it can be linear queue, circular queue, all those type of things. Okay. So first go for this one. See, the statement is it is a sequence list. Okay. What is a queue? Queue is a sequence list where set or list of data where set or list of data gets represented, but unlike the stack, okay, but not like the stack, unlike the stack, here insertion and deletion occurs on different ends. See, here insertion and deletion occurs on two separate ends. Means insertion occurs on another end and deletion occurs on another end. And insertion always occurs at the rear end and deletion always occurs at the front end for queue only. Okay, so that is the only difference between stack and queue. Okay, in stack insertion and deletion both occurs from the top of the stack, and here in case of queue operation insertion occurs at the rear end and deletion occurs at the front end. That's why, so if this one is our one queue structure which is represented like an array structure, we will see that deletion will occur from the front end and the insertion will occur from the back end. Okay, how when we will go for this particular example it will be much more clear. So as insertion is occurring at the rear end and deletion is occurring on the front end, so from there we can say that it follows this algorithm. Okay, these two are basically same algorithm, means first in first out or last in last out. Means that particular data which is entering first going to get deleted first, or the data which is entering at the last moment is going to get deleted at the last moment also. Okay, so here look at this particular example. Okay, this example. So here these are the action or status which we are following. Okay, this is a particular, we can say, pointer, okay, which is right now directing or pointing to the front end, and this is another pointer for the rear end. Why do we regard this front and rear? In order to know whether there is empty spaces in the queue or not, or whether the queue is totally empty. So basically front and rear end is going to help us for what? Front and rear end pointer. These pointers are going to help us in few things. First thing, front and rear end can tell us whether it's in underflow condition or overflow condition. First, second thing, if we are inserting any kind of data, the front end can easily tell us that whether the whole string is occupied or not. Okay, or we, as I said before, underflow overflow condition. Or from the rear data, okay, from the rear pointer, you can basically find out that up to which point or up to which locations, okay, by the rear pointer, we can basically find out that up to which locations the data is already getting occupied. Okay, from the front pointer, we can basically find out that which particular data is going to get deleted. Okay, so these are the first Sunil Shetty. বাহ, আমি তো ফেমাস হয়ে গেছি, ঠিক আছে। So next one, so let's go for the example, and this is the queue. Okay, this is the queue structure which will be like this one after the representation. So look here. So see, initially before starting anything, initially our queue is totally empty. Okay, so that's why our front pointer is also in 0 and rear is also at 0. So it is very much easy to tell that there is no data since the front and rear both are in the same. Okay, and both are in 0. Okay, but think about this one, where if both of them, okay, we will go discuss that one later, but first see, both of them are in 0 position, means the total queue is empty, so insertion can occur. Okay, first thing. So as we can see, since our front and rear pointer both are in 0, 0 position, so this is the initial one. Okay, this one is the initial one. So right now the initial queue image is like this one, the total empty queue. Okay, our next step, it's saying that insert A comma B comma C. Okay, so we are going to insert these three data one by one. Okay, so first what will happen? Insertion is going to start. Okay, so first insertion of A will occur. So first this insertion will occur. So front will update itself with 1. Okay, means the data which will be get deleted first will be getting deleted from which location? You guys tell me. I am right now just inserted A, and right now our front is at 1 and rear is at 1. So what is the significance of these two things, front and rear, from the image? Tell me if you can understand it or not. Hello?
Sir, can't understand the question. Please repeat.
What I am saying, see, here are our two pointers, front pointer and rear pointer. After insertion of only A, okay, ignore these two, BC ignores these two. After insertion of A, our front pointer is getting updated with 1 and our rear pointer is getting updated with 1. So what is the significance of this 2 1? Okay, why front is getting updated with 1 and rear is also getting updated with 1? That's why.
Sir, I think the front always inserts at the beginning and the rear inserts after the inserted elements.
No,
Sir,
no, no,
up to which place that is occupied?
no. The front pointer is going to tell you, see, right now A's location is 1. Okay, so front pointer is getting updated with 1 because as we know in case of Q, deletion always occurs from the, deletion is always going to occur from the, for Q, tell me, কি
Front.
বললাম
Front.
এক্ষুনি? Front end.
Front.
So whenever the data, which will be the first data, will going to get deleted, that will be this particular A, because this one is the first data, first in, first out, or last in, first out. So that's why this one is getting updated. Means our, if I am starting deletion operation, this one will tell us that first delete A. Okay. Then if we want to delete B, then it will update itself to 2. And this particular one is telling us that after which the Q portion is occupied. And if I want to do the insertion, the next pointer means here the algorithm will be after insertion of A, the pointer, the statement will be +1. So after 1, when B is getting inserted, obviously the rear will be, our rear will be updated with 2. Means at the rear end, we have occupied 2 places. So 1 and 2, and after insertion of C, this particular rear end will be updated with 3. So basically after insertion of A, B, C, our front end is right now at 1 because this is the first position where the data got inserted, and this will be the first position from where the data will be deleted, and this is the position up to which the data is already getting occupied. So our next, if we want to do the insertion operation, so our pointer will be easily pointing out that you have to update the next location, 3 plus 1 location. Okay, like that. So that's why this one is in 3. Okay, is it clear?
Yes, sir.
Okay, very good. So next operation here we are performing is delete A. So we are deleting the element A. So as we know, insertion occurring at the rear end and deletion occurring at the first end, and first in, first out means if A is getting deleted, so A is where? A is at 1th position. So if A is getting deleted, so the next one which will be deleted first will be our which one? If A
Sir,
is
B.
getting deleted, B.
B.
So that's why B's position is getting updated in the front end in the next one. That if our next deletion operation is going to occur, that will be from the 2th position. And as it is, that if I am doing any kind of insertion, that will be after 3rd position. So this one is as it is. So see next one. Next, we are again performing insert D and E. So as we see, or as the algorithm knows, that up to 3th position the data is occupied. So obviously the next data will be inserted into 4th and 5th position. So see, 4th position and 5th position the data got inserted, and since this particular data is getting occupied in the 5th position, and as we know our Q is here for this particular example is having 5 positions. So the front end, which was previously 2, it stays remain unchanged, and after the insertion of these 2 elements, this rear end is getting updated with 5. So that means that if I am inserting any kind of element, that should be before 5, it will be after 5. Okay, so see here again, deletion operation is occurring. So delete B comma C. So B is in 2th position and C is on 3rd position. So 2th position, second and third element will be deleted, and the next element which should be in line to get deleted first will be on the 4th position. So that's why 4 is getting updated in the front end and rear end was 5 as it is. Okay, next here, see, we are performing another operation, that is insert A. But as we can see, we have only 5 locations here: A, B, C, D, E. A, B, C, D, 1, 2, 3, 4, 5. And as we can see, the data is actually occupying on the 5th position. So if the next data which should be getting inserted, so that will be on the position of 5 plus 1, so it should be on 6th position. But here, as we can see, that here in our queue structure, here we don't have the 6th position. So from here, the concept of circular queue comes, that if this one is the 5th position, if our rear end is pointing at the 5th position and there is no data on the front end, okay, then we can easily say that the data will be shifted to the next.
And so what will happen if there would be data in the front position, first position?
If the data is in the front position, insertion will be simply tell you what under actually overflow condition, that there is no place for insertion operation.
Okay.
Okay, we will come to that logic when we will discuss the programming code. Okay, but here, here this thing is first thing. Okay, this condition, this particular condition, I am after explaining, I am telling you this one. So see, after this one E, so obviously the E is right now at 5th position. So our if this one and if not, this is a circular queue. So obviously the next insertion will occur in
front position.
1th place. Why this one is we are using circular queue? Because this one is a simple example of 5 locations. Okay, so we can easily say that after each deletion we can shift the data. Okay, but when we are dealing with a bigger number of data, that will become a very costly affair for shifting the whole data on the front end or on the left side after each deletion. So that's why we use the circular queue concept. First thing. Second thing, this particular condition is going to tell you whether your queue is empty or not, or whether insertion is possible or not. Look at this one. Previously, whenever we were following this one, see, the front end is 0, rear end is 0. So front equals to rear, no issues there. Front is lesser than rear, front is lesser than rear, front is lesser than rear, front is lesser than rear. But here in this particular case, we are seeing that front has become higher than the rear. This is the particular condition when we will be able to understand that whether the data, or sorry, not data, whether the queue is empty or not. Because if there was no empty spaces, this particular one, if there was no data, is let's say if this one, we are deleting B and C from here. So here, condition, check this one, insert F. So if this one was A, B, C, if these 5 locations are already getting occupied, then obviously our front end will be, instead of 4, this will be, this one will be what? If all the data are occupied, so our front end will be, bolo kotho hobe? Instead of 4, eta ki hoto bolo? Actually, bolo?
Front to one ही होते ना.
সেটাই তো জিজ্ঞেস করছি. Then if all the data were occupied, then our front end would have been 1, and the last entry point was F. So this one was 5. So if all the data are occupied, okay, if all the data are getting occupied, obviously this front end will be always lesser than the rear end, and only in case of circular condition, means when there are empty places after inserting the last element in the queue in normal structure, at that particular moment only the front end will become higher than the rear end, otherwise it will remain unchanged. এইখানে এখন কি আছে, 1 এ আছে ফার্স্টে, মানে যদি টোটালি অকুপাইড হয় তাহলে কি হচ্ছে, ফার্স্টে 1 এ বসে আছে আর রিয়ার এন্ডটা আমার কোথায় আপডেটেড থাকবে, 5 এ। তাহলে আমার নেক্সট ইনসারশন হতে গেলে কি করতে হবে? ফার্স্টে আমাকে চেক করবে, আমরা যেটা কোডে দেবো সেটা হচ্ছে ওভারফ্লো কন্ডিশন আছে কিনা। ওভারফ্লো কন্ডিশন চেক করার সবচেয়ে ইজিয়েস্ট উপায় কি? ফার্স্টে আমাকে চেক করে নেওয়া যে আমার ফ্রন্ট এন্ড আর রিয়ার এন্ড কোন পজিশনে আছে। ফ্রন্ট এন্ড যদি আমার ম্যাক্স কিউতে থাকে আর রিয়ার এন্ডও যদি আমার ম্যাক্স কিউতে থাকে, তাহলে আমার ইনসারশন করার কোনো জায়গায় নেই। ঠিক আছে, তো ওখানে আমার ওভারফ্লো কন্ডিশন স্যাটিসফাই হয়ে যাবে, আমি ওখানে ইনসারশন করবো না, বেরিয়ে চলে যাবো।
মানে স্যার একটা জিনিস শুধু চেক করতে হবে যে যদি ফ্রন্টটা লেস থাকে, ফ্রন্টটা যদি লেস থাকে রিয়ারের থেকে তাহলে অনলি মানে আমরা ইনসারশন করতে পারবো।
ফ্রন্টটা যদি লেস থাকে রিয়ারের থেকে তাহলে হচ্ছে আমরা ইনসারশন করতে পারবো সবসময়, ঠিক আছে, কোনো ব্যাপার না। কিন্তু এটাও আমাকে দেখতে হবে যে রিয়ারটা আমার ম্যাক্স কিউতে পৌঁছে গেছে কিনা। মানে ধরো দুখানা পয়েন্টার, ফ্রন্ট এন্ডের জন্য এটা ম্যাক্স কিউ, rear end এর জন্য এটা max q. যদি both of them are staying at the max q, then obviously there is no place for insertion.
ঠিক আছে হ্যাঁ।
So that was one example. So just move this one. Okay, proceed. So as we can see that our front end has become higher than the rear end. So this also satisfies the condition that this one is a circular cube instead of a linear cube. So our next insertion is going to occur at the F position. So as we know, see, A got first deleted, B got first second deleted, C got then deleted. Then obviously our next deletion is our D. So that's why this one is 4. Okay, sorry. Next one is our 4, and our insertion is occurring at this particular first end. So that's why our rear end or rear pointer got updated with 1. So our insertion is occurring on this particular position F. Okay, so let's come to the next line. So here again we are inserting G and H. So our insertion has occurred at the 1th position. So obviously G and H is going to enter in the 2th and 3rd position. So what will happen? G and H got updated in the 2th and 3rd position, at this position and at this position. So that's why, as previously, front end was 4, because the next particular one which was in line to get deleted, that is D, and that is in 4th position, and G and H obviously they are getting inserted here. So after the insertion operation, if we want to do the next insertion operation, here we can see the next insertion operation is going to occur at the 4th position, and which is already occupied. So 4 and 3. Next is our again delete operation, that is D and E. So D and E, so this one is getting deleted from 4th and 5th location. So the data is getting deleted from 4th and 5th location. So see, here the insertion operation has, the deletion operation has occurred. So 4th position is getting deleted. So first this 4 is going to get updated with 5, means the next one which will be in line to get deleted, that will be E. And then this particular one will be again get deleted, because we are deleting both these two, D and E. So 5th position will be getting deleted. So these two positions will become empty spaces, and this one, the next one which will be in line for the next deletion operation, that will be the 1 or the F position or the 1th position. So that's why our front end or the front pointer is getting updated with 1. Okay, and we have inserted up to FGH. So obviously the next one should be 3 plus 1. So 4th position. So these two locations. So that's why this one is 3 as it is, like the previous one. So again we are performing insert I. So obviously it will remain unchanged. This one will be updated with 1. So 3 plus 1, 4. So we have FGH and 4th position in I. Next we are again performing delete of F. And as we can see, the 8th is the 1th position, which particular data is going to get deleted, and then the next deletion will be on this particular position. So that's why this one is getting updated with 2. This one is getting updated with 4. Okay, any doubts?
স্যার কেন এই লাস্টের জায়গাটা খুব খিচুড়ি লাগলো আমার, বুঝতে পারলাম না।
আচ্ছা, দেখো আগের পজিশনটা দেখো, ইনসার্ট আইটা দেখো, ইনসার্ট আই পর্যন্ত কোনো ইস্যু আছে?
আমার না ওই ইনসার্ট GH টা বুঝলাম, ঠিক আছে, তারপরে DE টাই মানে ওইটা পুরোনো ডেটাটাই আমরা দেখছিলাম যে করতে হবে, এটা তো আবার যেটা মানে আগের একটা আগেরটা দেখছি কেন ওই তোমার আপনার ডিলিট DE টাতে। স্যার আপনি 6th আর 7th লাইনটা একবার বলুন না।
এক মিনিট। আরে Okay, second, see again. Okay, I'm not going to repeat it. এইটাতে করবো না ওয়ার্ডে করবো, ওয়ার্ডে করি, এটা তো সুবিধা হবে। One position, 2th position, 3rd position. এটা দরকার নেই, ফ্রন্ট এন্ড রিয়ার এন্ড, আর এখানে আমার একটা দুটো তিনটে চারটে পাঁচটা ছটা সাতটা আর একটা নেই, আটটা। এটা ভুল হচ্ছে, চারটে এখানে তিনটে ফ্রন্ট রিয়ার আর এইটা হচ্ছে এনাফ, ঠিক আছে। আর এখানে আমার দরকার হচ্ছে পাঁচটা, 1 2 3 4 5, 1 2 3 4 5 কটা লোকেশন আছে? 10টা, ঠিক আছে। ঠিক আছে, বুঝতে পারবে এটাতে? কমপ্লিকেট হয়ে যাচ্ছে।
হ্যাঁ স্যার, ঠিক আছে ঠিক আছে, আপনি বলুন না, ওই জায়গাটা বুঝলেই হলো।
আচ্ছা ঠিক আছে, দেখো আর কোথায় গেল? আমি শুধু এইটুকুনি লিখছি, হ্যাঁ, শুধু আমি উপরের শুধু ইনসার্শন অপারেশনটা দিচ্ছি, হ্যাঁ, দেখো ফলো করো। সো look at this one, এটা দেখে দাও, এটা দেখারই দরকার নেই, ঠিক আছে। So first, initially what it's saying that initially our stack is empty, right? So আমার এখানে পুরো জিনিসটা এমটি আছে, ওকে। সো ফার্স্টে আমি কি করছি, ইনসার্শন, আর ধরো আমি এখানে পয়েন্ট করে দিই 1 2 3 4 5, ঠিক আছে। সো ফার্স্ট আই এম ডুইং আওয়ার ইনসার্শন অপারেশন, দ্যাট ইজ ইনসার্শন অফ এ। তাহলে ইনসার্শনটা আমার কোথায় হবে বলো?
ওই তো ফ্রন্টে।
So first insertion will be A here, next insertion will be B here, and next insertion will be C here. Okay, now you already have this data. আমি এখানে আরেকটা দিদি তোমার হচ্ছে front আর হচ্ছে rear. So now tell me one thing, that front end, okay, front end is 2.1. Front end is 2.1. না ফ্রন্ট এন্ডটা আমার কি কাজে লাগে? ফ্রন্ট পয়েন্টারটা আমার কি পয়েন্ট করে?
মানে যেখান থেকে মানে এলিমেন্টটা স্টার্ট হবে সেটাই?
না, যেখান থেকে আমার ফার্স্ট ডিলিট অপারেশনটা স্টার্ট হবে।
আচ্ছা হ্যাঁ, ডিলিট অপারেশন, হ্যাঁ।
ডিলিট আমার ফ্রন্ট এন্ডে হচ্ছে, আর ডিলিশন ইজ অকারিং অন দ্য ফ্রন্ট এন্ড, or insertion is occurring at the rear end. So front end will point out that which particular data is going to get deleted. And this one is following the algorithm what? First in first out or last in first out, means the data which is getting inserted first will be deleted first. So here which particular data is getting inserted first?
A.
So the deletion will be also for
A.
So that's why front end is 1. Okay. Rear end is going to tell you that on which particular location
data is going to be inserted.
Data is going to be inserted.
4.
So that will be 3. That will be 3. That up to 3th position our data is occupied. ঠিক আছে, আমাকে যদি 4th দেখায় তাহলে আমার পয়েন্টারটা মাই জাস্ট কখনো ভয়েডও দিয়ে দিতে হবে। That's why we keep this one on the last position where the data is being inserted. Okay? So whenever we want to insert, that will be our pointer plus 1. Okay, the next insertion will occur. So insert is right now at A, and we insert, so this one is A, B, and C. So A, B, C. So next our operation is our delete A. So if delete A, A is getting deleted. So obviously right now this one
Pointer
will
is
be
at
only left
2.
with B and C, and front end will be changed to
2.
front end will be changed to 2. Is there will be any changes in rear?
No.
No. Okay, very good. Next, we are performing operation in here. Insert D and E. So obviously D and E will be getting inserted in the.
4 and 5.
So D got inserted here. E got inserted here. So this particular rear will be getting changed to.
4.
Hat,
Oh, rear. Acha, 1.
hat.
না
কি
মানে
বললাম যে
5
বললাম যে পজিশনে থাকবে সেখানেই পয়েন্ট করব।
হ্যাঁ 5
Insert D and E got occurred here. So right now, after doing the fourth step, this one is 2, this one is 5. Next one is our delete operation of B and C. So first, obviously, the first one will be getting deleted, that will be B, and then C will be getting deleted. So this particular 2 will be getting up front, will be updated with
4.
okay. So next is our insert operation F.
Insert F.
So this one is our circular cube.
So it will get updated to 1.
So this particular one will be inserting at the 1th position. The rear will be updated with 1. So see, previously front was always lower than the rear, but right now front is getting higher than the rear. This one is a circular position. So usually আমি ঘুরে এখানে ঢুকছি, তাহলে তো আমার ঢোকার কোনো মানে কনসেপ্ট ছিল না। যদি আমার এটা লিনিয়ার কিউব হতো, আমার ফ্রন্ট এন্ড কখনো রিয়ার এন্ডের থেকে হায়ার যেতে পারবে না। এই ধরো এখানে 100টা লোকেশন আছে, যাই হোক না কেন, আমি যদি 98 লোকেশনেও দাঁড়িয়ে থাকি, আমার 99 লোকেশন সবসময় 98 এর থেকে হাই হবে না। তার মানে only circular queue concept তোমাকে দিতে পারে, where front will become higher than the rear. So আমরা এখানে কি করলাম, কোনটা করলাম insert of A. So front is right now at 4, means the first data এটা মুছে দিই,
That is to be deleted is D.
ঠিক আছে, and our next data insertion occurred at here, that is our F. Next one is our insert G and H. Okay. So next insertion is occurring here. So আমি এটাকে আপডেট করে দিচ্ছি, G and
H.
So G and H got updated here. So obviously the rear will be right now updated on the which position? 3. 3 পর্যন্ত আমার হচ্ছে অকুপাই হয়ে বসে আছে। Next one is our delete operation of D and D. So obviously we also know that the first deletion operation is going to happen at the 4th and 5th position. So 4 will be removed, 5 will also be removed. So what will happen? The front will be updated with 1, because F is the next one in line to get deleted. Okay, and rear will remain unchanged.
না কোনো ইস্যু নেই।
তাহলে D কে উড়িয়ে দাও, D কে উড়িয়ে দাও। So right now this is the structure. Then next operation is occurring, it's insert I. So I will be getting inserted
at 4.
So rear will be updated with
4.
4. So the next, if we are performing any kind of insertion operation, that will be in the 4+1 position, okay, 5th position. But here we are performing a delete operation. So F is getting deleted from the 1th position, and again we also know that this one is the next one in line. So front will be updated with
1. ওই F তো ডিলিট হলো তো 2, হ্যাঁ।
এটাই তো আছে।
আচ্ছা ঠিক আছে আমি না কনফিউজ হয়ে গেছিলাম একটু। ঠিক আছে, থ্যাংক ইউ স্যার। হ্যাঁ।
Okay, so now we will go for the program code. এটাই আছে। Yeah. I guess that one is clear for everyone. The cube.
Yes, sir.
Okay, so now see, we are performing algo insert operation. So see, first we are checking for our insert operation. Okay, so what is the program? Algo q insert. So what do we need? We need the q name, so that's why q, the front pointer, the rear pointer, the max q position means the updated means the last position of the q, and item, that particular item which is going to get inserted. Okay, now see, for the overflow condition, if front equals to rear plus 1, so check this one. যখন টোটালি অকুপাইড, এখানে তো আমি ডিলিট করে দিয়েছি। Okay, just do one thing. This one. So insert G and H. So after doing the insert here, H, G টা এখানে চলে এলো, and H is coming at this position. Okay, so 4 will be the next insertion position, right? কি হচ্ছে বলো, আমার নেক্সট ইনসারশন কোথায় হবে? এইখানে হবে, ফোর্থ পজিশনে। So H is our right now at 3, and our deletion operation is also going to start from here. Okay, and that is our which position? 4. 4 start হচ্ছে আর 5 start হচ্ছে। So one condition can be that when front equals to rear plus 1, okay, means the front end is telling us that if we are to just plus 1 position, and that is becoming our rear position. It কখন হতে পারে? Just consider this particular image. Okay, so insertion operation is occurring. So 1th position এ A ঢুকলো, 2th position এ আমার B ঢুকলো, 3th position এ আমার C ঢুকলো, আর এখানে ধরো আমরা D দিলাম, E দিলাম। ঠিক আছে, so this one is for
স্যার
বল।
স্যার বলছিলাম ওই কোডিং এ ওখানে রেয়ারের ভ্যালুটা কি বাইরে স্টোর হচ্ছে ইনক্রিমেন্টের জন্য?
কোনটার ভ্যালুটা বলো?
ওই যে এখানে
রিয়ারের ভ্যালুটা? হ্যাঁ,
1 আছে না, এখানে তো ইনসার্ট হচ্ছে, তাহলে তো রেয়ারের ভ্যালুটা তো বাড়বে।
ইনসার্ট হচ্ছে বলেই তো, সেই জন্য তো রিয়ার ইনসার্ট হলে তো শুধু রিয়ারের ভ্যালুটাই চেঞ্জ হবে, ফ্রন্টের ভ্যালু তো চেঞ্জ হবে না। ডিলিট হলে ফ্রন্টের ভ্যালু চেঞ্জ হচ্ছে, তাই না?
শুনতে পাচ্ছি না।
বলছি রিয়ারের ভ্যালু কখন চেঞ্জ হবে? যদি একমাত্র ইনসার্ট হওয়ার সময়। ফ্রন্টের ভ্যালু কখন চেঞ্জ হবে? একমাত্র ডিলিট হওয়ার সময়, তাছাড়া তো ফ্রন্টের ভ্যালু চেঞ্জ হবে না। ফ্রন্ট আমাকে কি পয়েন্ট করছে? যে আমার নেক্সট ডিলিশন অপারেশন কোন পজিশন থেকে হবে, তাই তো?
হ্যাঁ স্যার।
হ্যাঁ, তাহলে তুমি যদি সেটা বুঝতে চাও, তাহলে তো আমাকে এখানে ফ্রন্টের পজিশন নিয়ে তোমার দরকারই নেই। আমি তো এখানে ইনসার্টেড নিয়ে করছি। ফ্রন্ট পজিশন আমাকে বলে দেবে যে এই ধরো এই পার্টিকুলারলি এটা সার্কুলার কিউতেই কাজ হচ্ছে। দিস পার্টিকুলার কিউ ইজ ইন circular queue mode. Okay, and right now after insertion of D, E and deletion of A, B, C, again we have inserted A, B and C. So what will happen? Next one, which one will be deleted? That will be D. Okay, just get the concept. Previously it was, let's say, X, Y, Z, D and E. Okay, so first X got deleted, so front got updated with 2. Next Y got deleted, front got updated with 2, and then 3, and then Z got deleted and front got updated with 3. Okay, and here the insertion has occurred at D and E. So rear is right now at the 5. Okay, up to this one any doubt? এখান পর্যন্ত কোনো ইস্যু আছে? আমি যেটুকুনি বললাম এক্সাম্পলটা ধরো
না।
Okay, so right now our front is in, this particular one is going to get deleted, so front is at 4 and rear is at 5. Okay, sorry, 4 এ কেন থাকবে? 4 এ থাকছে না, 3 তে থাকছে, sorry. Okay, so our next insertion operation is going to occur at A. So this one is getting updated with A. This one is getting A was 1. Then this one is going to get inserted 2. Then this one is going to get inserted with 3. Okay. And then after coming here, we are seeing that rear end, this one is already at this particular position, এখানে বসে আছে ডিলিট করার জন্য, fourth position থেকেই তোমার ডিলিট হবে নেক্সট পজিশনটা। নেক্সট আমার যে ডিলিটটা হচ্ছে ফ্রন্ট এন্ডে, এইখানে যে আমার নেক্সট ডিলিশন, the next deletion process is going to occur from where? Fourth position, and we are inserting from 1, 2, 3, so obviously the rear end will be at the 3rd position. So if these things are not deleted and these things are getting inserted, then what condition is occurring? That if I am going to insert the next operation, that will be in the 3+1 position, and that will be on the 4th position, but our 4th position is already occupied with the data D, so obviously this one is overflow condition. No, there is no data to be inserted here. বুঝতে পারলে কি না? তাহলে আবার বলছি।
আরেকবার বলুন।
বুঝতে পেরেছি। Okay, now consider this one. Previously there was data X, Y, Z, D, okay, and they got inserted as a queue operation will insert. Okay, so this one is 1, 2, 3, 4, 5. কোনো ইস্যু আছে? উত্তর দাও তাড়াতাড়ি, টাইম নষ্ট করো না। বুঝতে পেরেছি আমি কি বললাম এখান পর্যন্ত? Is there any doubt up to this one? আরে বলো, চুপ করে বসে আছে।
নো স্যার।
এক্সাম্পলটা ক্লিয়ার হলো তো ফার্স্টে কি বললাম আমি?
হ্যাঁ স্যার, হ্যাঁ স্যার।
তো সেটা রিপ্লাই দাও। Okay, so now next to write at this time of movement. Okay, so at this time our front end will be at what position? 1. Okay, but first our deletion will start from here, and our rear end is right now at 5. Okay, এইখান পর্যন্ত আমার ইনসার্ট হয়ে বসে আছে, so if we want to insert anything, that will be in the 6th position if I am considering there is a 6th position. Yes or no?
Yes, sir.
Okay, so first I am saying that X we are deleting, Y we are deleting, Z we are deleting. So right now the front end will be on which position? বলো front end টা কত হবে? Front will be, front কত হবে চেঞ্জ হয়ে?
4.
4.
Because our next deletion will be from D and then E, and now I am saying this one is a circular queue and we are starting to insert again. Okay, so I am inserting A here, so rear got updated with 1. Next I am inserting D here, no deletion operation is occurring. Okay, so rear will be updated with
2.
Next insertion operation is occurring here again, see, so rear will be updated with
3.
So there is no deletion operation in here, and all these positions are occupied. So right now see, our front end is at
4.
Because this one is going to get deleted first. Okay, because this one is the oldest one. Okay, just তোমরা here মধ্যে চিন্তা করো, the architecture আমি যেটা পড়েছিলাম যে first in first out কি ছিল, which one was the oldest one? Right now D1 is the oldest one and C is the newest one, means this particular one will be deleted at last and this particular one will be deleted first. So front and rear is basically is going to tell you which one is the oldest one and which one is the newest one. So from here front end is telling you D is the oldest one, means this particular one is going to get deleted first, and rear is telling you that C is the newest one, means this one is the newest one, means if we want to go for an insertion operation, that insertion operation is going to occur in which position? কোন position insert? No, মানে লোকেশনটা বলো, which particular location? That will be 3 plus 1, 4.
হ্যাঁ।
তো সেটা এখানে কি, and for this particular example if we want to do the insert operation, is there any possibilities to do that? Because we
No.
have the data being occupied in here.
Overflow condition.
So that's what we are saying, that if front equals to rear plus 1, okay, if front equals to rear plus 1 means if we want to going to insert the data at that position means, and we are finding out that that place is already being occupied because front will be at that particular oldest point where the data is going to get deleted first. এবার বুঝতে পেরেছো এই লজিকটা front equals to rear plus 1 কেন ওভারফ্লো কন্ডিশন করছে?
Yes sir, yes sir.
Yes, sir. Yes, sir.
ঠিক আছে, আরে বাপরে গলা ব্যথা করতেলাম। Okay, next one. Or another condition that will be front equals to 1. Okay, next condition is telling you that front equals to 1. So if this is the normal insertion operation, just consider this one. This is your cube. Okay, and normal insertion operation has started. So first A got inserted, then B got inserted, then C got inserted, then D got inserted, then E got inserted. Okay, then our rear will be কত হবে বলো? Rear will be 5 and our front will be
1.
will be 1. So if front equals to 1 means no data got deleted from there. Okay, কোনো data delete হয়নি, তাহলেও আমার overflow condition, that's also a reason for overflow condition because none of the data got deleted from there. Okay, and rear equals to max cube. Okay, rear is also standing at the max cube means there is no place for the next insertion operation, and we are also finding out our front is also on the first position means there is no place for means that nothing got deleted from that particular place. So that particular moment means if this particular condition occurs, then you can't insert any kind of data in there. So that's also a reason for overflow. Clear about the two overflow conditions?
Yes sir.
Yes, sir.
Okay, so now if these two conditions are not there, then that's not an overflow condition means insertion operation is going to occur in there. So else what we can do, we are going for if front equals to null means if there is no data inside the queue, so that will be if front equals to null means void. Okay, if front is right now in the 0th position means the whole queue is empty, then we can insert the particular first element and we can update that front equals to 1 and rear equals to 1. Why? Because when we are inserting A here, so what is going to happen, the first data which will be getting deleted from here, that will be A, and the next data which will be in line to be get inserted, that will be in the correct position. So front and rear both will be updated with 1. Okay, if the queue is totally empty, then this particular one, ঠিক আছে, এই particularটা এটা গেল, clear হলো? Okay, else if rear equals to max cube, okay, if rear equals to max cube, এই পজিশনটা আমার কখন আসছে, এই পজিশনটা আমার এইখানে আসছে। দেখো, if rear equals to max cube for this particular operation when we are doing insertion of D and E, so D and E, so rear is at our max cube position, right? Our rear to max cube position and B and C is getting deleted. Sorry, so right now our rear is in max cube position. So if rear is in max cube position means in this position, then rear equals to 1. We are switching this one in a circular mode. Then rear is going to get updated because at this particular position we can't perform +1. Okay, rear +1, because if we perform rear +1, that will be 5 + 1 and 6. 6 is there is no place for 6 means that the pointer will go in void position. Okay, so if we are facing max cube position, okay, and since though we have already checked that there is no overflow condition is there, so obviously this one is if and this one is a circular queue, then our algorithm and code will be that if the rear end is max queue position, this 5th position, obviously our next insertion is going to happen on the 1th position. Yes or no?
Yes sir.
Okay, so that's why this one. Okay, so here as we have done this one for insertion of F, insertion of f. Insertion of f. See, previously the rear was in 5 and our first insertion is occurring at the 1th place. So if rear equals to max q, if our rear is standing at the max q position, then our next insertion operation is going to occur at the 1th position. So this particular one is also complete. Else, if this one is in normal position, means the if this one is in normal condition, that means rear is pointing at the 3rd position. Okay, rear is pointing at the 3rd position or the 3rd position. Then what will happen? The next insertion is going to occur at rear plus 1.
Fourth position.
So that is, and if these are the 3 conditions which can occur at the time of insertion, if overflow is not occurring. And after getting that particular position, q equals to rear equals to item, that particular position is going to get updated with the item. And when the total insertion operation will be done, we are going to exit it. So from here, clear about the insertion operation?
Yes, sir.
Okay. So now we are going to go for the deletion. Okay. So like this, like the previous one, algo q delete. So q name, front, rear, max q, and item. That particular max q position, the item which should be deleted, the front pointer, rear pointer, and the q name. Okay. Now see. So what will be the condition for underflow? The simple condition is only deletion is impossible if there is, or underflow condition can occur if there is no data within the queue, right?
Yes, sir.
Okay. So the first data which should be inserted or which should be deleted, it gets pointed out by the front end. And if there is no data in the queue, obviously front end will be in the 0 position. Or what, void position or null position? Right? Okay. So if only front equals to 0, okay. Because rear to check if front is equals to 0, obviously there is no data there, so obviously rear will be also at 0. Okay, so that is the simple thing. So if front equals to 0, then our underflow condition is going to occur. Otherwise, if front and rear is having at any pointer, there is data within the queue and deletion operation is possible. Okay, so else if that one is not in a underflow condition, item. Okay, so this one. So item q equals to front. Okay, items q equals to front means that particular one, which one is getting pointed, that particular thing is going to get deleted. That item equals to q equals to front equals to rear, and front equals to 0. See this particular condition, that if front and rear both are in same position. So let's say we are inserting A here, inserting B, inserting C. So right now our front is 1. Okay, our inserting D here, inserting E here, and rear is 5. Okay, any issues? ঠিক আছে? হ্যাঁ কি বললেন?
হ্যাঁ স্যার, কোনো ইস্যু নেই।
আচ্ছা আচ্ছা। So right now this is our queue structure. So first deletion operation, A is getting deleted, so front will be কত বলো? Front আর কি হবে? 2. Then B is getting deleted, so front will be
3,
C is getting deleted, front will be
4,
and E is getting deleted. No, 4 কেন হবে? Front কোথায় থাকবে? Next আমার
5 এ থাকবে, 5 এ।
So front will be
5.
front will be 5. So if this particular position is here, so this particular condition is appearing. Front equals to rear. Because if we want to insert any kind of data, so that will be rear plus 1, so 5 plus 1. Or as we have said earlier, that if that rear end is in max Q position, our next insertion is going to happen at the 1th position. So rear end for this particular queue right now, rear is at the 5, and again the data which should be deleted from this particular queue is also 5.
5.
So front equals to rear, right? Front and rear both are same. So if I am deleting this particular only element, then what is going to happen? This one is going to get deleted, right? So if that condition occurs, if only when that condition is going to occur, this condition is going to occur only at the time when there is only single data left in the queue. Otherwise, this condition is not going to happen. Front equals to rear, right?
Yes, sir.
Okay. So when front equals to rear, okay, means there is no place for insertion. Or let's say I am just saying that I have inserted A, I have inserted B, and I have inserted, let's say, C.
আচ্ছা স্যার, যদি অমনি করে যদি সব আবার ডিলিট হয়ে যায় তাহলে তো আবার একটা আন্ডারফ্লো কন্ডিশন চলে আসবে।
সেইটার জন্যই তো, that's the reason when we are facing, okay, so we are right now we have only 3 data in the queue. So first A got deleted, so front is becoming at এখানে 3টে data insert হয়ে যায়. So right now rear is at 3, sorry, and then first A got deleted, so front is right now at the 2. Okay, then B got deleted, so front is right now at the 3. Okay, so front and rear both are in same position. So this particular condition is stating when front equals to rear means a single data is only left in there. So if that particular data is getting deleted, so the front shouldn't be on the 4th position. If we don't switch this one into front equals to 0, what will happen? It will not going to check for the underflow condition. That what is happening here, that whenever we are facing that front equals to rear, this particular scenario, we should always update the front position to 0, because our next, whenever, if we don't do this one, okay, if we do not use this particular problem statement, this particular line in code segment, that front equals to rear when is happening and front, then we are assigning the front equals to 0. What will happen? Since this one got deleted, the front will be automatically, if we don't switch this one, the front will be in 4, right? So when it will go for any kind of deletion operation, whenever any kind of deletion operation is going to occur, it is always going to find that front is not equals to 0, but it's not going to find any data for deletion operation. So it can't check for the underflow condition, and again it is not going to find any kind of data for deletion operation. So obviously this one will be in a loop. First thing. Second thing is, if these, after facing this kind of situation, if we do not reset those 2 pointers, what is going to happen is that our next insertion, okay, so after totally emptying the queue, our operation is going to start from here. Okay, so that is not the main issue. If I am starting the insertion operation from here, there is no issue, because our front end will be at the 4th position and rear end is at this particular position. Okay, and it's going to insert itself. But first thing is the underflow condition. It's not going to find out the underflow condition in here. And second thing, the most important thing is here that we have inserted F4. Okay, we just updated after doing the deletion. If we do not reset this one, this front will be updated to here. Okay, 4, and this rear end is pointing you that this one is in 3 position. Okay, so your front is becoming rear plus 1, right? Your front is becoming what? Rear plus 1. So that is also a condition for overflow. So neither you can insert any kind of data, nor you can delete any kind of data. That's why we are resetting this one into front equals to 0. Is it clear?
Yes, sir, clear.
Very good. So next operation is our else. If front equals to max q, okay, our front is telling that particular front, for this particular example, again consider this one, let's say A, D, whatever, A for R, C. Okay, so previously this front is going to get deleted, so front will be updated with 2. So next this one is going to get deleted, front will be updated with 3. Then this one is going to get deleted, front will be updated with 4. And then this one is going to get deleted, so front is right now updated with 5. So if we are finding out, okay, that front equals to max q, means the particular data which is going to get deleted is in the max queue position, or the oldest data right now within the queue is in the max queue position. Then obviously what is happening? It's just getting incremented by 1. Okay, and another condition was that if this one was there, then front equals to 0. Then another condition that can occur, that is if this one is our front queue position, max queue position, so obviously deletion of this particular data, our next deletion operation should start from 1, because when we are doing the insertion of operation, we have already used that in our code, that if we are in max queue position, we are going to update the next insertion operation from 1. So obviously for deletion operation will be also the same, that if we are deleting from the max queue position, again we have to point the pointer to the 1x position, because our next deletion operation is going to start from there. So that's why else if front equals to max queue, if our front is right now at the max queue position, so after the deletion operation, this particular pointer or particular front pointer should be moved to the 1x position, because our next deletion operation is going to start from there. So that's why this particular line. Else if front equals to max queue, then front equals to 1. Clear?
Yes, sir.
Okay, and if this one is occurring in normal condition, means we are deleting 1 by 1 data. So obviously after deleting, if say if this is CV, so obviously what is happening? So right now, if this one is the structure, so this one is right now in the 1x position. So after deleting the front from 1, the front will be updated from 1 to 2. So front plus 1, then this 2 will be updated with again, and this one. So 2 plus 1, 3. So like this one is for the normal condition. So clear about the all the 3 conditions which can occur for the deletion operation. All of them are explained here.
Yes, sir.
Yes, sir.
Very good. Okay, next is our tree.
আচ্ছা স্যার ওই মানে ডিলিশন আর ইনসারশনটা কি একটা অ্যালগরিদমের মধ্যেই মার্জ করা যায় না?
একদম একসাথেই করবে। আমি এখানে আলাদা আলাদা দিয়েছি, অ্যালগরিদম তো নয়, এটা প্রোগ্রাম কোডটাই দেওয়া আছে।
হ্যাঁ মানে ওটাই।
হ্যাঁ একসাথে করবে, আলাদা আলাদা কেন করবে? তুমি আলাদা আলাদা প্রোগ্রাম থ্রাই করো, যখন ইনসার্ট আর ডিলিট করো কোনো কিছু,
সেই তো।
যাই হোক না কেন।
হ্যাঁ হ্যাঁ
ঠিক আছে, দুটো একসাথে করবে। একটা ওভার ইনসার্টের জন্য একটা রাখবে, ডিলিটের জন্য রাখবে, যেটা তুমি কল করবে সেই ফাংশনটাই কাজ হবে। ওকে,
হ্যাঁ হ্যাঁ ঠিক।
okay, so next one is our priority queue. Okay, so previously we have gone for normal queue, now we are going for priority queue. So what is priority queue? Priority queue basically tells you or works with the means insertion and deletion operation occurs depending on the priority of that particular segment. So here see, A data is having priority 1. Okay, B is having priority 2, C is having priority 2. Just ignore this one for the time being. Okay, so D is having priority 4, E is having priority 4, F is having priority 4, G is having priority 5. Okay, so whenever you are facing any kind of priority queue, you just draw 2 matrices here, one for front and rear, and another this matrix for depending on the number of priorities you have provided with. Okay, so here we have, you can put the priority number as it is 1, 2, 3, 4, 5. Okay, depending on the priority number. So whenever we draw the matrix, so this will be our priority sequence. Okay, priority number sequence. Okay, and that is our vertical wise. Okay, and horizontal wise, you are going to just place those numbers. Okay, or place those values. And this particular horizontal orientation doesn't have any kind of rule. You can put them anywhere there. The thing is that here we are starting here with A, means A is having the highest priority. Yes or no? Okay, A is having the highest priority. Okay, and always remember that whenever we are facing priority queue, this one is the 1 is having always the higher priority than 5 or 6. Okay, or 2 is having higher priority than 3, or 3 is having higher priority than 4. For this particular example, you can decide that on your own. Okay, clear up to this one?
Yes sir.
Okay, so now as we can see that A is having the highest priority here for this particular example. So these are the sequence number, normal sequence number horizontally, okay, not the priority number. This is the priority sequence, that this one has the highest priority, so this one is on the top, and this one has the lowest priority, so this one is at the low. And as I have mentioned here, priority number. Okay, so this is like this one. Here I have placed A at the 5th position. If you want, you can place A at the 2th position, 3rd position, 4th position, 6th position, 7, 8, doesn't matter. Okay, you can put A in any places, but just you have to remember that should be in the first row. Why? Because this one is having the highest priority. Clear?
This row will matter.
It doesn't matter. Okay, the sequence number doesn't matter. Okay, you can insert this particular 1, 2, 3, 4, 5, 6. This is basically your queue structure. Just consider this one as queue. So 1, 2, 3. Let me tell you 1, 2, 3, 4, 5.
মানে কলাম আমরা কিছুও দিতে পারি, রোটা আমাদের প্রায়োরিটি হবে।
রোটা কোথায় হচ্ছে? কলামটা তোমার প্রায়োরিটি হচ্ছে না?
এ তো স্যার ফার্স্ট রোতেই আছে, তো উপরে আছে।
হ্যাঁ, এ ফার্স্ট রোতে আছে। আমি বলছি রো এর কোন পজিশনে আছে সেটা ম্যাটার করে না, ঠিক আছে?
হ্যাঁ, রো মানে ওটাই বলছি, হ্যাঁ রো এর কোন পজিশনে আছে সেটা ম্যাটার করে না, বাট রো ওয়াইজ ম্যাটার করবে। হ্যাঁ,
Row wise matter করে।
হুম।
So right now, just for this particular example, here I have put A in 5. So just I am changing this one. Okay. So here A is having the first highest priority. So I am placing A at 4. Okay. Depending on this particular one, that where you are putting your position of A, you just have to update your front and rear. Why? Because for this particular example, see, I have put A at 4. So at right at this moment, our front and rear is very much necessary in order to do insertion and deletion. So A is right now the oldest data which should be deleted. That's why 4. And our next insertion operation is going to occur at rear plus 1 position. So rear will be also updated with কত বলো? rear কত হবে বলো?
রিয়ার তো 4ই আছে।
হ্যাঁ, তো 4ই হবে, সেটা বলো, কনফিডেন্ট হবে। So both of them in 4 position, because if we want to delete the data, this one is our oldest data, so that's why front is having 4. And if we want to do any kind of insertion operation, obviously we are going to insert that thing after that one, after
Right.
that position. So rear plus 1. So at this position, so obviously rear will be having 5. If I have inserted A in 3rd position, obviously our front and rear will be 3, 3. Okay, so here I have inserted, here we have inserted A at the 5th position. So that's why this front and rear got updated with 5. So if means if we are inserting any kind of data, that position will be at the 6th position, rear plus 1 position. And if we are deleting that data, then our first insertion, deletion operation is going to occur from the front end, and that is 5. Okay, clear about this line?
Yes sir.
Okay, very good. Next, as we can see, we are seeing B and C both are having second priority number 2. Okay, don't consider this one, don't consider the X for the timing. I will come to that next one. So as this previous one, we can again place B and C anywhere in this queue. Okay, just we have to maintain the front and rear position. So as we had first inserted B in this particular queue, okay, not this queue, there is another queue below that. Okay, so as we have inserted B and C, so first we have inserted B, so obviously this one is going to get deleted first, so that's why we have updated B with 1. Okay, sorry, B front with 1, and C got, then we have inserted C here, then our rear is also got updated with 2. Means our next insertion operation is going to occur at the,
So we could also have done the C at 6 and B at 6 and C at 1. B at 6 and C at 1.
yeah, you can do that, no issues there.
Mm-hmm.
Whenever you are inserting B at 6 and C at 1, that is also a very good thing to do, because at that particular moment your front will be what? Front কত হবে বলো?
6 হবে।
Front will be 6, means our first deletion operation is going to occur from 6, and your rear will be
Rear would be 1.
rear will be 1, means our next insertion operation is going to start from 2, rear plus 1.
Mhm.
No issues there, you can place them anywhere. Okay, just put them sequentially. Means right next to each other. Don't put them that you have placed B in 6 and you are putting C in 3. That's not possible. If you are putting B in 6, obviously you are going to put C in 1. Okay. Okay, right one after. Okay, next we are inserting. Next, as we can see, there is none of the element is having priority 3. So that's why we have put front and rear, both of them at the 0, 0 position, because there is no data to be deleted from here, so it will be very much easier for our underflow condition. And if we want to insert any kind of data, this is also going to tell us that the total queue is empty and we can insert here easily. Okay, so that's why we have pointed front and rear both at 0. Clear about the 3? I guess?
Yes, sir. Yes, sir. Yes, sir.
Okay. Next, we are having D, E, and F. All of these three is having priority number 4. So we have placed 4 here. Okay. So as you are saying earlier, let's see. Here we have inserted D at the 5th position. Then we have inserted E at the 6th position. And then we have inserted, obviously for the circular queue reason, F at the 1 position. So D is our oldest data. So our front will be at 5. So see, front is at 5. And F is our newest data, means the next data which should be inserted will be after this one. So that's why 1.
Here is 1.
So rear plus 1, the next insertion operation is going to operate here. So 5, 1, and this one is updated. And as we see, G is like that. Now, what is happening here? For instance, suppose if you want to insert a particular element within this priority queue. Okay, obviously you can do that. Suddenly you have found out that you need that particular segment of the data to work it. So you have just inserted a particular data. So first get node, okay, and you have put data X within it, and you have given this one the priority number 2. So what is going to happen there? First, this connection, okay. First a connection to the internal. First, what will happen? The rear end. Okay, obviously we know the rear end is going to tell you the next position, right? Here we are going for a singular fashion, okay, and monolithic position. So here we are finding out that this particular rear always going to point out the next element. And as you can see, this is only unidirectional, not bidirectional. Means this one can tell who is after him, but he can't tell who is before him. So as we need. So what we need, so you already know how to do that. So first we establish the rear end connection with the X, and then we updated this particular address at the rear end of this one. And since this two particular connection has been made, we can basically delete this particular connection, and we have seen that X is having the priority number 2. So what is going to happen? Previously B and C was there, and we are seeing that yes, rear end is at 2 position. Obviously, our next insertion operation is going to happen at 2 plus 1 position. So this one X will be inserted at this position, and rear will be updated with 3. Okay.
Basically, oldest connection will get deleted. Then the pointer will, then a new node will get created, and the next pointer will get connected to the data of that new node that is created. And after that, the end will get connected to the next data.
Exactly. And just previously what you guys have done, prep pointer, pointer. So prep pointer is going to mark you to the gate node where the data or the connection is going to be established. So first this new thing is going to update it from here. যেটা তোমাদের ইনসার্শন অপারেশনে তোমরা করেছিলে, যেখানে হচ্ছে আমরা তিনখানা পয়েন্টার ইউজ করছিলাম, পার্টিকুলার নোড where the node is being inserted. আচ্ছা কোথায় গেল ছবিটা?
আচ্ছা previous data and next. হ্যাঁ
এই যে ইনসার্শন আমরা করছিলাম, এখানে কিরকম হয় করলাম, কানেকশনটা এখানে আপডেট করে দিলাম, আর এখানে হচ্ছে এটাকে দিলাম, আর তারপরে কানেকশনটা আমরা কেটে দিলাম। Just simple like that. Simple insertion of any kind of node. You just have to write that code and the insertion operation will occur. ঠিক আছে? আরে তোর মানে এটাই তো পড়াচ্ছে। So that is our priority queue. Okay. Next we are going for binary tree. Okay. So binary tree. So there are few terminologies in here, and first clear these out properly. Okay. First thing is a binary tree T is defined as a finite set of elements called nodes, such that T here stands for tree. T is empty, called the null tree or empty tree. Means if there is no nodes and leaves in there, obviously there is no data elements within that thing, and then what we can say that the tree is empty, and for that particular reason we call that a empty tree or a null tree. Okay. Next thing is, if tree, okay, T here stands for tree. Tree contains a distinguished node R. Okay, so look at this particular example. Here, these are the nodes. Let me mark them: A, B, C, D, E, F, G, W means X, H. Okay, so these are the nodes here. Okay, so T contains a distinguished node R. Okay, what is our node? R is our root node. Okay, root node means where all these things started. Without a root node, a tree can't exist. Okay, means without a parent, a child can't exist. Okay, same thing. Like without the root node, a tree can't exist. So if A is not present there, okay, obviously B and C can't be present there. And if B and C is present there and A is also not, and A is not present there, obviously that means this particular one is a separate tree and this particular one is a separate tree. Because root node doesn't have any kind of parent or anything. Root node is the starting of the main thing. Consider this one as the unique cell or a single cell for the starting of our living being and all things. Okay? It is our first basic cell. The first key theory, first nucleus was created. Okay? Hey, nucleus chilo. Na to?
Sir, mitosis, meiosis, two daughter nucleus cell divide हो जाता.
अब भूले गए बहुत दिन आगे biology पढ़े. Okay, so that thing. So root node, without root node, a tree can't exist. Okay, and the top node from where the tree is being started, that is called our root node or R. Okay, called the T contains a distinguished node R called the root of tree. Okay, and the remaining nodes of the tree from an ordered pair of disjoint binary trees T1 and T2, and these are the normal trees. Okay, and here these things are called leaf nodes. Okay, these are the tree and these are the leaf node. This particular connection, okay, this particular connection, let's say this one is called edges. Okay, this thing is
স্যার ট্রিটা কি আজকে শেষ করে দেবেন?
কেন
স্যার আজকে না ওভারলোড হয়ে যাবে।
স্যার হ্যাঁ স্যার
মানে স্যার
ক্লাস আছে
আমার
স্যার
স্যার ক্লাস আছে স্যার একটা ওইজন্য বলছিলাম।
না ক্লাসে
স্নান
থেকে
করার
যেগুলো
time
পড়লাম
পাবো না
ওগুলো
আজকে।
ভুলিয়ে যাবে।
আচ্ছা ঠিক আছে, ট্রিটা আজকে শেষ করবো না, তুমি ট্রিটা কি আগে তোমরা আজকে জেনে নাও, বাকি আমি ধরো কালকে মানে পরের দিন হচ্ছে ট্রাভার্স করাবো, কারণ তোমাদের কাল আমি ক্লাস নিতে পারবো না, কাল আমার তোমার ইনভিজিলেশন ডিউটি আছে ফার্স্ট অফ। তো ঋষিকা তুমি আমাকে পরে একদিন একটু টাইম করে দিও তো, কোনো একদিন ফাঁকা করে দিও তো, যদিও তোমাদের 1 মিনিট দাও করে দিচ্ছি। তোমাদের ম্যাক্সিমাম আর 4টে ক্লাস লাগবে, হ্যাঁ তাহলে তোমাদের কমপ্লিট হয়ে যাবে। ওকে হ্যাঁ সে ঠিক আছে, আজকে আমরা ইন্ট্রোডাকশনটা কমপ্লিট করে দিই, হ্যাঁ এইটুকু, ঠিক আছে, বাকিটা আমরা ট্রি এর ভেতরে ডিটেইলসে কিছু ঢুকবো না, ট্রিটা কি সেটা জেনে নাও, ঠিক আছে আজকে।
রাত্রি করুন স্যার, আমার ক্লাস আছে।
কটা থেকে ক্লাস আছে?
2:10।
ও তোমাদের টিফিন টাইম না?
হ্যাঁ
আচ্ছা
হ্যাঁ
ঠিক আছে,
স্নান খাওয়া আছে।
আচ্ছা ঠিক আছে চলে যাও, পরের দিন স্টার্ট করবো। Drop your roll number in the comment box. Give my leave after.
থ্যাংক ইউ স্যার।
থ্যাংক ইউ স্যার।
থ্যাংক ইউ